Next example, we're going to use a contingency or two-way frequency table to help us calculate conditional probability. A two-way frequency table that you see down below here is often used to show the observed or relative frequencies of the data from an experiment classified according to two variables, with the rows indicating one variable and the columns indicating another. So our rows are going to indicate a treatment or control group. The columns are going to indicate whether they improved or they did not see improvement. Now this is a frequency table because it tells us how often 1,600 people said that they received the treatment, 1,200 received the control, placebo. 400 people said that they did improve, and 800 said that they did not improve. So these are frequencies. We're going to convert these frequencies into relative frequencies, which is the ratio. A ratio is a fraction of the number of observations in the statistical category to the total number of observations. So we're going to do some changing of this table here, which is a frequency table, and we're going to convert it into a relative frequency. So that's going to be one of the first steps that we do. So in our example, a drug company conducted an experiment to determine the effectiveness of a certain new drug. Test subjects are randomly assigned to one of two groups, a treatment group, which received the drug, or a control group, which received a placebo instead of the drug. The contingency table below shows the results. So as we mentioned earlier, we've got rows and columns describing the treatment control and whether they improved or not. In question A, this is where we're going to focus on our conditional probability. Find the probability that the test subject's condition improved given that he or she was in the treatment group. So we're asked the question, what if we knew that they were in the treatment group? Then what was the probability that their condition improved? So the conditional probability that we're going to be doing, the probability that the subject's condition improved, so yes, they improved given that they were given the treatment. So there's our conditional probability that we're going to calculate. So to do this, we're going to change our frequency table into a relative frequency. So I've added some columns to our tables. I got totals on here, and we're going to put in the totals that we're going to put in for how many people said yes to the condition improved. So we've got a total of 2,800 people said their condition improved. What's the total condition did not improve? Well, there's 1,200 people said their condition did not improve. We also want to run the totals across the rows. How many people received the treatment? And that was 2,000 people received the treatment. We want to do a total for the control group, how many people received the placebo, and that is also 2,000, which gives us a grand total of 4,000 people in our study. So what I did is I created a total. The next thing we're going to do is we're going to divide each of these frequencies by the total number of people in the experiment, so by 4,000. So in step 2, we're going to divide each observed frequency by the total number of people in the study, which was 4,000, to obtain a table of relative frequencies. So in essence, we're going to take every one of these numbers, the 1,600, we're going to divide it by 4,000, so I'll just get 4K. Take this, divide it by 4K, and we're going to repeat this process over and over again in our table. So that's what I'm going to do. I'm going to quickly put in those, and then we're going to come back and we're going to finish this problem. So I'm going to pause it, put in those to stop the calculations, and then come back. Okay, I filled in the table. If we did all of our calculations correctly, then we've got 4/10 of the people responded to the treatment said yes. 3/10 said in the control group said they improved. And if you notice the totals coming down here, these totals add up to 0.7. The totals coming down here are 0.3. The totals coming down here, half and half is a 1. And also totals coming across also add up to the correct responses. So we've just made a relative frequency table versus, let me get rid of those arrows just to clarify, rather than a frequency table. Now we're going to focus on our question. It said, find the conditional probability of y given t. And that's what we had written up there. What's the probability that they said yes, their condition improved given that they received the treatment? We're going to do the probability of that they received the treatment and their condition improved divided by the probability that they were given treatment. So we'll go find our numbers in our table. Where do we find the probability of that they received a treatment and they said yes? So we're going to go into our treatment group. We got a treatment and they said yes, their condition improved. That was 4/10 of the time, so 0.4. And then what's the probability that they received the treatment. So what percent of the time did they receive the treatment? And that is half the time, or 0.5. So using a little better color here, that gives us, if we simplify that, 4/5 of the time, or as a percentage, 80% of the time, people that received the treatment said that they had some relief in conditions that they improved. We have a follow-up question. It says, find the probability that the test subject was in the original control group given that, try to read again. Find the probability that the test subject was in the control group given that his or her condition did not improve. Okay, so I'm going to come back to that in just a moment. Once again, we're set up to find a conditional probability. Here's the probability event that we want to have happen. It says that we are given that his or her condition did not improve. So given that they did not improve, what's the chances, or what's the probability that they were in the control group? So we're going to calculate the probability that they're in the control group given that they did not improve. So we run through our calculations. We want to have the probability of in the control group and did not improve divided by the probability that they did not improve. So we're going to go up in our table and we're going to find where's the percentages that says they were in the control group and did not improve. So they are in the control group and did not improve. So here's our control group, did not improve, that is 2/10 of the time, so 0.2, divided by the probability that they were, or they said did not improve. So how many times did they not improve out of our total? That was 0.3. So we find both of those in our table, our relative frequency table, and that is 2/3 of the time, or about 66.7% of the time. And that's how we can use relative frequency charts or contingency charts to help us find conditional probabilities.